All right, let's dive into the secret world of matter. We're talking about the solids, liquids, and gases that make up literally everything you can see, touch, and even breathe.
So, have you ever stopped to think about this? You can skate on solid ice, swim in liquid water, and then barely even feel steam, which is just water as a gas. It's all the same stuff, right? H2O. So what's really going on here? Why does it act so differently?
The answer, believe it or not, is happening at a level that's totally invisible to us. See, everything is made up of these tiny, tiny particles. And what those particles are doing, well, that's the secret key to understanding the entire physical world.
Okay, so let's start with the most straightforward one, solids. Think of a brick, a piece of wood, or that ice we were just talking about. They all have some things in common. We all know the basics, right? Solids hold their shape. You can't pour a rock, and good luck trying to squash one. But you might have also noticed that when you heat up a solid, say a metal railing on a hot day, it actually expands a little. The big question is, why does it do all this?
To figure that out, we have to imagine we can shrink ourselves down, way, way down, and see the particles that everything's made of. So what would they look like inside, say, a block of ice? And here it is. Inside a solid, the particles are locked into this perfect, neat, regular grid. There are these super strong forces holding them all together so they can't just wander off. All they can do is just vibrate in place. Now, when you heat it up, you're just giving them more energy. That makes them vibrate faster and harder, and they start bumping into their neighbors, pushing them away. That's why the whole solid expands. Simple, right?
All right, so what happens when we give those vibrating particles enough energy to break free? Well, we get liquids. We know liquids. You can pour them. They take the shape of whatever glass or bottle you put them in. But their volume doesn't change, and you still can't really compress a bottle full of water. So what's changed down at the particle level?
Okay, let's zoom back in. We're looking at the particles inside a drop of water now. And right away, you can see that neat, orderly grid is totally gone.
And this is the key difference. In a liquid, the particles are still pretty close together, but they've got enough energy to break out of that rigid structure. Now they can slide and tumble and roll past one another. The best way to think about it is like a bucket full of marbles. And that's exactly why liquids can flow and take the shape of their container.
Now for the final state, where things get really wild and energetic, gases. Think about the air you're breathing right now, or the helium inside a balloon. Gases are a whole different beast. They don't have a fixed shape or a fixed volume. They just expand and expand to fill whatever room or container they're in. And unlike solids and liquids, you can very easily squeeze a gas into a smaller space.
So, you know the drill. One last time, let's zoom in and see what those particles are up to. And you'll see the jump from a liquid to a gas is even more dramatic.
Whoa! In a gas, the particles have so much energy that they've completely broken free from each other. They're just zipping around like crazy, super far apart, flying in straight lines until they bounce off each other or the walls of the container. This explains everything. It's why a gas fills any space it's in and why it's so easy to compress, because it's mostly just empty space between the particles.
So, this whole way of thinking, zooming in to see these tiny little spheres bouncing around, that's what scientists call the particle model. Let's just quickly get a formal handle on what that really means.
A scientific model isn't supposed to be a perfect picture of reality. It's a tool. It's a simplified way for us to understand something that's way too complicated, or, in this case, way too small for us to see directly. The particle model is a perfect example of a really, really useful tool.
This table just pulls it all together beautifully. You can see the clear pattern, right? Look at the arrangement. We go from a regular pattern to just random. For spacing, we go from tightly packed to close together to super far apart. And for movement, we go from just vibrating to sliding past each other to moving quickly and randomly all over the place. It's such a neat summary of everything we've talked about.
Now, just when you think you've got it all figured out, solid, liquid, gas, simple enough. Science just loves to throw us a curveball. What if I told you there's a liquid that can also act like a solid?
Yeah, let me introduce you to something called a shear thickening liquid. It's basically a substance that completely breaks the rules we just laid out. And the most amazing part? You can actually make this stuff in your own kitchen. No, really, it's incredibly simple. All you need is some corn flour and a little bit of water. You just mix them together gently, and pretty soon you'll have this really strange slime.
Okay, so here's where the magic happens. If you slowly dip your fingers into it, it feels like a liquid. Your fingers just sink right in. But if you punch it or stir it really fast, it instantly becomes hard as a rock. You can even scoop some up and roll it into a ball in your hands, but the second you stop applying that pressure, it melts right back into a puddle. How cool is that?
And that kind of leaves us with this really fascinating final thought. We've got our neat little boxes for solids, liquids, and gases, but then this cornflower slime comes along and shows us that reality is always a little bit weirder and more complex. It really makes you wonder what other strange states of matter might be out there, just waiting to be discovered.